triangle, right? So we're going to talk about the law of sines and law of cosines. And so what we want to be able to do is, if I give you any triangle, if I give you some angles and some sides, I should be able to tell you every angle and every side. Okay, so that's the game plan. We're going to start off with 7.1, which is the law of sines. Bear with me, I'm going to derive this thing. So we know what it's going to do. Whatever the law of sines is, whatever the law of cosines is going to be in the next section, it's got to do something that we have not seen before in terms of relating angles of a triangle to the sides. I'm going to have to put down two equations. Actually, it is two equations. It's actually three equations and one line. And there are going to be some angles and there are going to be some sides, all in the same equation, right? And so that type of thing allows us that if we have some of the angles, then we can find some of the sides. If we have some of the sides, we can find some of the angles. Okay. All right. As you might guess, we are going to start with a triangle. And there are a couple of, the first thing I want to do is make a remark. Here's the remark. And here's the triangle. The first thing to remark is that this triangle is not a right triangle. And so that should come away with gasps like, oh no, what are we going to do now? We don't have this magical 90-degree angle anymore, right? So I would also like to talk about notation. This is my MATLAB notation. Capital letters are going to refer to angles. Lowercase letters are going to refer to the lengths of sides. So this is going to be capital A, and the lowercase letter is always opposite the angle that is the uppercase letter. So this would be capital B, this would be little b, this would be capital C, and this is little c. And for me, of course, I have to make sure that my C's are small enough if they're the side and big enough if they're an angle. The first thing I want to do is I want to talk about the area of this. Right? What's the area of a triangle? Half the base times the height, right? Area of a triangle is half the base times the height. The way that you can prove that is that the area of a parallelogram is base times height. Right? The area of a rectangle is base times height. The area of a parallelogram is the same because the parallelogram, you just push the rectangle over, but it doesn't change the area. Right? And every triangle is half a parallelogram. Right? So if the area of a parallelogram is base times height, then half of that is half the base times the height. So I want to talk about the area of this first. In order to talk about the area of this, I need to know the height. There's the height right here, right? I need to know the altitude. Now the altitude is defined to be the length of the line segment from one of the vertices, in this case C, to the line that contains the opposite side. So that technically the altitude could be outside the triangle, right? So if I had a triangle like this, right, and I would wanted to know the height is outside the triangle, and that is perfectly okay. Right? That would be the height, whatever that is, right? But in this case, it's on the inside. Okay. I'm going to come up with a formula for the height, or for the area, right? So this is H, and oh my goodness, if we knew A and we knew B, right, and we know C, maybe, we would be able to find out what. Is there a way we can relate capital A to H and B? Sine. The sine of A is equal to the opposite over the hypotenuse, right? The height is equal to B, the sine of A. Okay? This is actually B, the sine of A. Okay? So then the formula, the area of this triangle is equal to half the base times the height. Questions about that? Is it okay? Now the great skeptic comes in, and the great skeptic says, yo, what type of mess are you trying to pull? Right? Is this going to work no matter how I turn this triangle? Right? If I turn this triangle, I don't think this thing's this good, right? Can I grab this triangle? Let's see here. Is that going to let me grab it, is it? No, I want to grab the whole thing. Let's do this. I'm going to grab the whole thing like this. Right? I want to take this thing, right? Like that. And then I'm going to put it here. Right? And what I want to do is I want to rotate it. How do I rotate this thing? Oh, I think it's like this, right? I want to do this. Order? No, rotate. I know there's a way to rotate this thing.
Like that. That work?
I don't think so.
Like on the corner?
Oh, here?
Your picture right there on the left. You go left.
Rotate, here we go. So now, if I rotate this thing, rotate it 90 degrees, like that, right? That's still not going to give me what I wanted. But what I can do is, I'll do my best to do it. Then I can take this thing, and then I can make CB the base instead. That's C, that's B, this is A, right? Who knows how it's going to look. But suppose I took the same triangle and just rotated it, right? Little c, little a, little b, right? And I perform the same argument. And I say, well, wait, this is now the altitude. And I do the area then. I want to know what this is now, what the new altitude is, and I run the same argument. What do you think the area is going to be for this one when I lay it down this way? I'll run through the argument again. I know that the sine of C is H over B, and so H is equal to B, the sine of C, right? The area would be 1/2 the base times the height. So I hope we see the pattern that if you have an angle and the sides, right, if you have two sides and the angle in between, then you can find the area. It's 1/2 AB, the sine of the angle. If you have an angle and the two sides that make the angle, then you can write the area. Okay. And finally, if I turn it on the other side, what's the other way? It would be 1/2. What's the one that I've left out? So the one we just did was 1/2 BC, the sine of A. What's the other one?
B.
Say it again. Is B, what is it? We have BC. We have AB.
It's B.
Which one are we missing?
Half of B.
Half of,
B.
what would the letter be? AC, the sine of B. Okay. 1/2 AC, the sine of B. So when you have A, then you use the two sides that make A. When you have C, you use the two sides that make C. When you have B, you have the two sides that make C. Or the street version is leave that letter out. Right? Leave that letter out. Now, all I'm doing is playing around with triangles. Has the area changed? All of these are equal. All of these are equal. And from this, we'll get the law of sines. I'm going to set them all equal to each other. And then we'll be able to relate angles and sides. All of those are just different ways of calculating the area of the same triangle. They all have to be equal. I'll just do the first one. I'll set these two equal to each other. These are now equal. So 1/2 BC, the sine of A, equals 1/2 AB, the sine of C. What do they both have in common? What can we drop off of both sides?
B.
The 1/2 and the B. C, the sine of A, equals A, the sine of C. Right? And if we divide both sides by A and divide both sides by C, then you get the law of sines, that the sine of A over little a equals the sine of capital C over little c. And you can demonstrate by the same argument that that is the sine of capital B over little b. This is the law of sines. So we have three equations here, right? This is equal to that, this is equal to that, and then this is equal to that, right? How might you solve this now, right? So now, if I have capital A, little a, and capital C, then I can clearly find little c. Because here's an equation where there are 4 unknowns, but now I have 3 that I can simply solve for the other one, right? So if I have those 2 angles in this side, then I can find that side. And by the way, if I have those 2 angles, obviously I can find the third angle and then find the third side. If I have 2 sides and the angle in between, is that good enough? 2 sides, if I have A, B, and C, right, that may not be enough. We may need to do something else. But if you have 2 angles, if you have 2 angles in any side, the law of sines works. 2 angles in any side, the law of sines works. Okay. Questions about this? Well, all we're going to do is a bunch of these. We're going to use this, and then we're going to run into some problems. Right? And then you have to rectify those problems. Okay. I guess I should talk about the problems now. That it's not trivial just to make a triangle, right? So there are going to be some issues making a triangle. The first thing about triangles is that in order to make a triangle, no one side can be longer than the combined lengths of the other 2 sides. Okay, so you can't have a triangle with sides 3, 1, and 7. That's impossible. 7 is just too long, or in other words, 1 is too short. Right? You can't have a triangle where one side is longer than the combined lengths of the other 2 sides. Okay. There's some other issues too. Here's what we want to do. So we're going to give you some sides and some angles. Right? So I'm going to give you a triangle like this, right? Right, and I'm going to give you some stuff, and we're going to bring it back right here. GeoGebra is free, by the way. This is called GeoGebra. Actually, I wanted to make an angle. Sorry. Don't do that. Stop. Okay, just get rid of that thing. Okay. So now I want to put in angles right here. They're the angles, right? And the sides are right here. Okay, so that's a beautiful thing, right? So there are going to be some conditions under which we won't have a triangle, right? In which a triangle won't be possible to do, okay? Let's see what those conditions are. So then when I look at this, I'm just going to grab this point, right? So what is this side now, right? So this side is 3.61, right? That's A. A is 3.61. And suppose I have this side, suppose I have this angle. So this is called the ambiguous case, okay, that we're talking about. So the issue is that sometimes you're not going to have a triangle. Sometimes a triangle is not going to be possible. Sometimes you can get only one triangle with this property. And sometimes you can have 2 triangles with this property, right? So suppose I gave you an angle. I gave you alpha. Alpha has to be 45. I told you that C has to be 4.24, right? And I told you that A has to be 3.61. Okay, suppose I told you that, right? So here's the problem. The problem is that in that case, there are 2 triangles that I can make with this property. Here is the first one. Okay, now I'm about to draw another one that has an angle of 45 degrees, a side length where C is 4.24 and A is 3.61. Right? Do you see how to draw it? I would simply take this point and I would just need to move it in this direction. If they're going to, I'm going to move it in this direction. Now just watch A, right, until it gets back to 3.6. Was it 3.61 or 3.16? It's not going to matter. I can make it, right? There it is. That's the second triangle. Okay. So why is it that this one has two? It has something to do with the fact that the length of B was more than the length of A. When the length of B is more than the length of A, then you're going to get two triangles. Okay, so that's something you need to check from the beginning. When the length of B is more than the length of A, then you can swing one of the sides over and make a second triangle. We're going to do that. When, and we'll summarize all this in just a moment, when the length of A starts off really long, this is the only triangle. Right? If I said that find the triangle with these properties, right, an angle of 45 degrees, the length of C is 4.24 and the length of A is 10.44, that's the only one, right? There's no way I could swing this over and make this work. Okay. So in that case, there's one and only one, right? So when A is bigger than B, when the length of A is bigger than the length of B, we have no issues, and we're going to find that one triangle. Okay. Sometimes there won't be a triangle, and it's when A is too short. The question is, well, how do we know what too short is? Well, there's a minimum value for what the length of A should be. You know how short A can be? Can you see how short A can be? It would have to be the what? What would it be? Tell me when A is its shortest. I'm going to move this. You tell me when A is the shortest I could make it to make this triangle. Where is it? There, right? If I leave, so when it's the height, right? If A is smaller than the height, I cannot make this triangle. Right? So what you'll see in my math lab is that when they're doing these, they always compare A to the height. Because if I give you a triangle that you want to form and A is less than this, then I can't make it. Because that's the smallest A can be in order to make the triangle. Right? That's the smallest A can be in order to make this triangle. That one. Okay. And you can see why that is, right? Because if I moved it farther along, what happens? That this right here is a triangle, isn't it? And A has to be longer than the height because it's the hypotenuse, right? So A can't be any longer, okay, can't be shorter than the height of the triangle. Okay. And we know how to find the height, right? It's, you just take, it's C, the sine of the angle. Okay. Ton of theoretical stuff there. We're going to start doing some examples. The first couple of examples, A will be bigger than B, or A will be bigger than C, and then we can just go ahead and find the one triangle. And then as we go along, they'll give you the triangle, and then they'll give you three choices. And the three choices are, there is no triangle with this property. There's only one triangle with this property, and here it is. Or there are two triangles with this property, and here it is. All right, let's hit the homework. Sometimes you'll be given a picture and sometimes you won't. And so it's good to remember the notation. Here is the first one. Can we see that? Should I make it bigger? Actually, I'll copy this one. Here, this one we don't have any issues. What have they given us? They've given us two angles and a side. Okay. This is not a right triangle, yet we're going to find every angle and every side. They've given us two angles. At that point, we should be salivating because it is trivial to find the third angle, right? We have 118 degrees so far allocated to A and C. That leaves 62. Is that right? 62 degrees is the remaining amount. 80's there, 88's there. So again, B plus 30 degrees plus 88 has to be 180. And you just solve for that. All right. We need this length right here. Well, the law of sines, we have capital A and we have little a. The law of sines says that the sine of 30 degrees over 9 equals the sine of 62 degrees all over the thing we don't know. And now we're going to solve for B, and it's all calculated from here. As you might expect, your calculator should be in degrees. So we're going to cross multiply and get B by itself. We're going to be doing a ton of cross multiplying. We'll do this procedure ad nauseum. Cross multiply, and we'll then divide by the sine of 30, and it's all calculator. Let's see what that is. We got to practice this now for sure, right? So when we put this in the calculator, this goes 9 sine 62 slash sine 30, and then we're rounding. Will B be larger or shorter than 9? Will B be, say it again?
A bit larger.
A bit larger, why? In a triangle, the larger sides follow the larger angles. Right? If you have a big side, it means that the angle needed to make it needs to be larger, right? So we said that that angle was 62, then that means that side B has to be longer than side A because the angle is 30. Right? So this is the way of kind of checking yourself, that whatever angle you get for whatever you get for B, it needs to be more than 9. What is it? It's not more than 9?
15.8.
Say it again?
15.8.
15.89, what's happening? Round to the nearest 10th, 15.9? 15.9. Again, all calculator at that point. Are we putting it? You got it? Okay. This is exactly what's going to happen on the test. So make sure you know to plug this stuff in. Try C. Try and get C. Right. So for the same reason, the sine of 30 degrees over 9 is equal to the sine of 88 degrees over little c. The sine of 30 degrees over 9 is equal to the sine of 88 degrees over little c. Cross multiply and do the same thing, right? Sine of 30 degrees over 9 equals the sine of 88 degrees over little c. And we know little c has to be the largest side because it is opposite the largest angle. You do this enough, you'll see that we're going to get this thing, right? 9 sine 30 degrees, right? Cross multiply, divide. 18 even?
Or if you round it,
I think it's rounding to one decimal place, right? To the
it's 17.989.
yeah, 17.989, yeah, 18, approximately 18 even. Okay. Questions there? So this case is not ambiguous. If I give you a triangle with two angles on the side, you're good. It's only when, and you know it, you'll know it by the initials, it's only when you have an angle side and a side. So that's when we don't want to be making mistakes, right? But for this, two sides, so we've taken care of angle, side. angle, side is taken care of for the triangle. If you're ever given two angles on the side, law of sines. Just like whenever you're given a function where the unknown's in the exponent, we have to use logs. Whenever you're given a triangle and you have two sides and an angle, you can always get every side and every angle using the law of sines. Okay. This one here, what is that? That is, again, angle, side. Right? Same thing. All right, so we'll motor through this. So then we've got, we got capital C. Capital C is the remainder. That's 94 degrees. What's left? 86 degrees. Okay. And then we can roll through this. The sine of, you want to use 58? Sine of 58 degrees over 106 is equal to, what do you want to solve for first? B, sine of 36 over B, and you're just going to do the same thing. Okay, so I may leave this to you as we're just doing the same thing. Cross multiply, B, the sine of 58 degrees is equal to 106, the sine of 36 degrees, and then B is equal to 106, the sine of 36, all over the sine of 58. And we're all at the calculator. And you do the same thing for C. Two angles at the side, it's over. Okay. So that includes angle, side. And by the way, when I say angle, side, I mean just reading the information that you have as you go around the circle. We have this angle, we have this angle, and we have this side. Right? That's all we're saying. But again, if you have two, so basically we're saying if you have two angles and any side, right, then you're good, right? Because then you automatically know this one. And so that also includes angle, side, angle, right? So, as well. Okay. Questions about this? Anyone want to see little c being done? No, thank you. So then if we want little c, then we have the sine of 58 degrees over 106, we're still going to use the information given to us just in case we made a mistake, is equal to, now the 86 we're pretty confident about because we can subtract. The sine of 86 degrees all over little c. Again, we're going to cross multiply. Then c, the sine of 58 degrees, is equal to 106, the sine of 86 degrees. And then we're going to divide. Little c is equal to 106, the sine of 86 degrees, all over the sine of 58. Just plug into the calculator around the 1 decimal place. Typically, MyMathLab wants you to round all degrees to whole numbers and round all sides to 1 decimal place. Right? So because at some point later today, we're not going to have the degrees. You're going to have to find the angle. Right, and it wants angles as whole numbers. Questions about this? Okay. So that's 3. All right, now they won't give you the triangle. They just give you these letters, right? And so with this, again, as I said before, you have a standard triangle where you have capital letters R. So you can draw this if you want. It may help to draw this, right? So you've got, draw it however you want here. This is not going to be to scale, right? And so here you've got 44 degrees, right? That's A. Little a is 6. And we could put B here, 47 degrees. And then we'll just do the work, right? So then that's 91. That leaves 89 degrees here. That's almost a right triangle, right? And then you do the same thing. All right, so 3 and 4 are exactly the same way. 4 is interesting because it's acute. I'm sorry, it's obtuse. It has a big angle in it, so I may want to do that one, see if anything interesting happens. But yeah. It's all the same.
Yes.
Yes? We're going to see this one? Okay. So then we've got the sine of the one that's given, sine of 44 degrees over 6 equals the sine of, we've already labeled this as 89, right? The sine of 47 over little b. Cross multiply, same stuff. All right, we'll keep rolling until there's an uprising that says, yo, I think we got it. 37 degrees over the sine of 44. All sines. C. I'll do C, and then I'm going to leave the other ones to you.
That's how you get.
Thank you.
That's how you get little b.
That's little b, yeah. That's little b, yeah. And I use 47 degrees because it's capital B.
So
Yep.
after that, you get 5.5.
Do you?
Yeah.
Okay. Then 5.5, and that's what goes here, yeah. I'll take your word for it. Yeah. And C rolls the same way, right? So sine of 44 degrees over 6 equals the sine of 89 over little c. And at some point, we'll become so good at this. 6 the sine of 89 over the sine of 44.
So no matter what we use, what number they give us, like 6.
Yeah, only because I know this one's the one they gave us. I know it's right.
Alright.
Yeah, so I'm always going back to the one I know that was given to us. Yeah. So yeah, by the fourth problem, it might just get tedious, but again, it's just practice. And then, yeah, we'll go into interesting examples after that.
So
Yeah.
we were trying to find A.
Little a?
Yes.
Little a was, oh, for number 4?
Yes.
Yeah, so tell me, what would you do?
Is that 172 or 1?
It's 122, yeah. So then it would be sine of 36 over 140, right, equals the sine of 122 over little a. Yeah. There's not a lot left for b here. 158, 22 degrees. So b is super small. So we would expect side b to be much smaller than all the other sides.
Because you did 122 plus 36.
And then there's only, and the whole thing has to be 180.
Alright.
That's right. That's right.
And then a little bit.
Yeah. That's right. Let's see what the other ones say. Three, what is that saying? Side angle. Right, so this is precisely what we're talking about. The subtlety. I'm sorry, I didn't mean to do that. So here, I wanted to increase the view. So zoom in. So now we have side angle, and A is longer than B. There's only one answer to this. If, as long as A is long enough, right? As long as A is long enough. Okay, so, and you'll see this very clear in, and maybe we should just go ahead and write out all the possibilities. Okay, so they do this in pretty well in MyMathLab in giving the table of what you have to do, right? So when you click on view an example, they'll go through what you have to do in order to make sure which one it is. So what we said is that here we have A and the opposite side and the opposite angle. So we have A and little a. And so B is also given, right? And there are a few things we need to check. we need to check that, first of all, that A is bigger than the height of the triangle. If it's not, then there can't be a triangle, right? We have to check that A is bigger than H. Okay. So we need to figure out what H is in just a second, right? Then we need to check that the relationship between A and B, right? So that B is bigger than A, or whether B is less than A, right? If B is bigger than A, then there's one triangle. If B is less than A, I'm sorry, there are two triangles here. There are two triangles, because that allows me to sweep the A through. If B is less than A, if A is long enough, then there's only one triangle to make. Okay. And again, that's going back to this picture, right? That if we started off with a triangle that was really small like this, then that side right now is again 3.16, and I can certainly make another triangle with length 3.16, right? With no problem. But if our triangle started off way like this, there is no other triangle that I can make with that side length other than that one, right? So so in this case, this is supposed to be B, right? So if B is less than A, there's one triangle. If B is bigger than A, then like this, then I can certainly make another one, right? Right. So you'll see that there are a couple of things to check. So you need to check the height, its relationship to the height, and then you need to check the relationship between B and A. Are there any questions about these conditions? And again, my math lab breaks it down, going through those steps pretty nicely. But that summarizes it. We had already done a good job finding the height of any triangle, right? And so, but let's just go ahead and do it one more time. I got this triangle here. Oh, what are you doing? I got this triangle. Where should I put it? I'll put it here. So I got this triangle here. So I got, who knows what it is? I've got A is 40 degrees. I got 6 here. B is 5, right? So B, A, I don't know that, right? So the question is, how does it relate to this? And it's the same formula every single time, right? We'll do it this one time, deriving it one last time. That the trig function that relates 40 degrees to h and 5 is sine. So the sine of 40 degrees is equal to h over 5. And so the height is always the hypotenuse times the sine of the angle. Right? So then you actually have to calculate that. Right? So now the question becomes, is 6 more than 5 sine of 40 degrees? The answer is yes. Maybe you can tell me how I do that before you even put it in. What do we know about sine? It's always less than 1. It's always less than 1. If I multiply 5 times something that's less than 1, you're going to get something less than 6, right? So good. So A is long enough. We can make a triangle. And now because A is bigger than 5, A is bigger than B, there's only going to be one triangle. And now we get to find it just like we were doing all the other ones. Okay. One triangle. Now this game's over, right? We just get to the business of finding, and I think they want everything, right? They want every side and every angle. So right now they provide us with the sine of 40 over 6 is equal to what? The sine of over 5. The sine of what? B over 5. Right, so this is our first foray into finding an angle. Okay, now we have to find the angle B. we're still going to cross multiply, or we can just multiply the 5 on the other side, right? The sine of B is equal to 5 the sine of 40 degrees over 6. Okay. And now, how do I have free B? I have to do what?
Inverse.
The inverse sine. The inverse sine. Heavy calculator time. B is equal to the inverse sine of 5 the sine of 40 degrees over 6. All calculator now.
32.4.
32.4. They want you to round to the nearest whole angle. 32.4, but we want the nearest 32 exactly, right? We do need to practice that. Try and put that in your calculator, see if you get 32. And the TI goes, you press the inverse sine button, it gives you the parentheses. You then need to put, it doesn't hurt to put another set of parentheses, 5 sine of 40, close parentheses, divided by 6, close parentheses. I was told that was 32 degrees. That's less than 40, and it better be, because 5 is less than 6, right? The size of the angle goes with the size of the side, right? So yeah, if that fits, it's usually almost guaranteed to be right, right? Again, if you had gotten 48 degrees, you know that you're wrong, right? The angle has to be smaller because the side opposite is smaller. Excellent. All right, so then we got 2 angles now. We can immediately go get C. We got 40, we got 32. That's 72, leaves 108. I'm sorry, is that for A? That's for C, right? Yeah. So that was A. We found B. Once we have 2 angles, we just go get the third one, right? And then now, again, using what was given, the sine of 40 degrees over 6 is equal to the sine of 108 over that final side that I don't know.
So this will be all right on paper?
So I am tempted, so this is not, well, this might be one of the 6 problems. So one of the 6 problems that I have to give is some triangle problem that I didn't look at hard enough, but it probably is going to be one of these. Yeah, so you're going to have to write this out probably. And if it's not one, I probably am going to put this on the final. Right? I've been giving so much build up to it, right? I still have it. But it won't be difficult, right? So I don't think I'm going to do the ambiguous case. That's a lot of reasoning, so which is not bad, but it just takes some time. Cross multiply. C, the sine of 40, equals 6 the sine of 108, and then C is 6 sine 108 over the sine of 40, and that thing should be huge.
8.9.
Say it again? 8.9, so yeah, it has the other ones crushed, right? It's clearly the longest side. The angle is 108 degrees. It's the largest angle in the triangle, so it should be opposite the largest side. We'll work through all of these. As you might expect on the homework, we'll go through every possible example. We just did one that has 1 triangle. There's going to be one with no triangles, and there's going to be one with 2 triangles, right? So let's see. That was 4, 5. Let's try this one. 11, 16, and 70. Start before me and see. Don't let me catch you. A is 11, B is 16, A is 70. Let's get some steps out so that we just know exactly what to do. Okay. Let's get some steps out. Here's the triangle. I don't need any of the directions because I know that if I'm given 2 sides and an angle, that alerts need to go off. That there might be 1 triangle, there might be no triangles, there might be 2 triangles, right? So let's get some steps out. 1, you need to check the height. we now have a formula for the height. The height is the height is B, the sine of A. The height is always B, the sine of A. Now, if they're being bad and they switch the letters, you still the other side sine of the angle that you're given, right? So if they told you capital C, if they gave you little c and capital C, and then little b, then that would just be capital C. Right? But they're being good with the notation, I think. Right? So let's calculate that first, and hopefully 11 is more than that. If 11 is not more than the height, then we cannot make a triangle.
I got 15.
Is it? 15. So the height, so it's 16, the sine of 70 degrees.
Yes.
Roughly,
15.
we're rounding to one decimal place for these things. 15.0. Okay, so 15. So if A is less than the height, then no triangle. Right? And again, going back to the picture, that's because here we have it. If A is less than this, then I have no chance to make it down here. Right? I can't get down here if it's less than the height. No matter where it is, this height right here, if it's less than that, it's no way it can touch the base. Right? This one, the answer is there's no triangle that has these properties. No triangle. And we'll write the steps out for the next one, which probably has 2 triangles, okay?
So on my map, it will say no triangle.
Yeah, that's right. Let's look at what it says. It gives you 3 options. Yeah. So then it's A, there's only 1 triangle, and here are the solutions. B, there are 2 triangles, and here are the angles and sides of that first triangle. Here are the angles and sides of the other triangle. They distinguish the triangle by the angle B. Okay, and then C, there are no possible triangles. Yeah, so then for this one, I'm sorry, it was this one, right? For this one, it's C. There are no possible triangles. A is too short. So again, this is what we mean by completely ending discussion about the triangle. We know when they exist. We know when to find them when they do exist. We know how many exist, right? Of course, we know, to give a preview of what we're going to talk about, we know that the law of sines is insufficient, right? Because if I just gave you 3 sides and no angles, this thing is completely useless, right? So that's why we do need something else, which we'll be talking about in the next section. All right, let's hit it. For 2, we're not surprised by that, 2 sides and an angle, A is less than B. Can we swing that over to work?
You said 15 what?
I'm going to put it right here. Yep, it's 15, 16, and 50. All right, let's get the steps out again. So now, if A is bigger than H, then we will be able to find 2 triangles. Right? So 1, check the height.
12.3.
Say it again?
12.3.
Is it? So H is B, the sine of A. In this case, it's 16, the sine of 50. And it has been shown that that is roughly, what is it? 12.3 to 1 decimal place. Right, so if A is less than H, no triangle. If A is bigger than H, at least 1. And now, this is a decision tree. I got some iTech people in here, right? Just a decision tree. If A is bigger than B, then 1 triangle. And if A is less than B, then two triangles. When I get really good at GeoGebra, I'll be able to throw all of this throw this triangle up and play with it.
So this one has two triangles?
That's right, because 15 is less than 16, and I think it's barely going to squeak in there, but we'll see.
You might answer this question, but
Yeah.
H is a height, right?
H is the height, that's right. That's right. When the A needs to be larger than the height for this to work. All right, I want to draw this triangle. Oh, do we have this written? I'll leave this here for just a second so we can get it written down. I'll take a picture. We're going to go ahead and do this, and we're going to get one triangle for capital B, and then we're going to see that there's space to create another one. Right? We're going to create another one. We'll see how to do that. Question? Go ahead. Go ahead.
How do you know how big the height is? Like you said, check the height.
Yeah, here's the formula.
Yeah.
It's B the sine of A. You will have both B and capital A. So the first thing we did was derive what the height of a triangle is. If you have two sides and the angle in between, the height is B the sine of A. So if B was 16, A was 50, put it in the calculator, it's 12.3.
All right.
Yeah, so find that number first, and then compare it to A to make sure we should even get started. Because if the height, if A is not bigger than the height, then I can't even make a triangle. Right? So this is the first condition you have to pass before we even start looking for it. Yeah. Okay, let's find it. Let's find both of them. Okay, so all right, so then we're talking about, and we got to watch super carefully where this is going to show up, right? And so this is going to be about B. There are going to be two B's that show up. Let's see where it happens. The first is we've got the sine of A. Well, we have it, right? So the sine of 50 degrees over 15 is equal to the sine of B over 16. Right. And so we'll multiply the 16 on both sides. So the sine of B equals 16 the sine of 50 over 15. B is the inverse sine of 16 the sine of 50 over 15. Say it again?
Did you get 4.8?
It should be around, it should be slightly bigger than 50. That's right. So that sounds just about right. They want you to round to the nearest whole number.
Yes. Oh, so it's 55?
55. Okay. Is that okay? I'm going to draw this picture now. So now here it's all over. We can go find C now, right? We can go get C, which is going to be 75. And then we can go find little c. Right? So I'm trying to see whether, yeah, let's go ahead and finish this one triangle off. So B is 55 degrees, and so now capital C is 75 degrees, right? Right, it's the remaining amount, right? We have 50, 55, 105, needs to add up to 180, right? And so we got that from 180 minus 50 minus 55, right? That's where we got it from. So now we need little c is the only thing we don't have, right? So little c, again, sine of 50 degrees over 15 equals the sine of 75 over little c.
Well, we wanted to, we could like, remember we had got 12?
For what? For the height. For the
Height, can we put 12 under that sine 50 if we wanted to?
No, the height has nothing to do with the, yeah. Cross multiply c is equal to 15 sine of 75 all over the sine of 50. What's that number? Say it again? 18.9. That makes sense. That's the largest angle, right? Okay. 18.9. So that checks in as the largest side, which makes sense. Okay. Okay. So there's another triangle we got to go get. Okay. But here's the first one, right? And B is 55 here. And now the other one is going to be something slightly different. I want to draw a picture so we can see it. So you can tell me what the other angle is. Here's what we had. We had this, right? We had this. And here's what we just found. Okay, we have something like this. And this almost works, right? So here's capital A, right? Here is little a. What was little a again? 15 or 16? What was little a? 15? So that was 50, right? This was 55. This was 16. Okay. And so now I want to get this other triangle. We've seen this picture many times. I'm going to take this side right here, and I'm going to keep the same length, and now I'm going to move it over this way and create an obtuse angle. Okay? So all I'm going to do is now copy this line and bring it over here, right? What's the length of it? 15. Okay, so what does that make this angle? For this isosceles triangle? That's also 55. Is that okay? Because this is a triangle and two of these sides are equal, the opposite angles have to be equal. That automatically tells you what this should be.
125.
The rest of it, 125. Okay. That should be 125. Okay. So in order, the new B is just 180. It's just the supplement. The new B is just 180 minus the old B. Okay. For that very reason. And now we have a new angle for C. Okay. So now that's 50, that's 125. Oh, is that really? That's what I meant by it squeezed in barely. This squeezes in barely. That's a very small 5-degree angle. So this is moved all the way over here, right? So it's barely in there, but it's there, right? So then this is 5 degrees. And so now the new triangle, right? Or the other triangle, right? You get by doing 180 minus the old B, right? Gives us the 125. And then that means that the new C new, is 5 degrees. And now the only thing we don't know now is the new little c, right? So then the sine of Old Faithful, right? 50 degrees over 15 is equal to the sine of 5 degrees over little c. And oh my goodness, little c is going to be super small, right? Little c is equal to 15, the sine of 5 degrees. And we know the sine of 5 degrees is really small because the sine of 0 is 0. 1.3. Is it? Uh-oh. Get this right. 1 point what?
Did I put it in wrong or something?
Yeah, you better make sure, right? 1.7. And again, that makes sense. That needs to be super small because the angle's really small. Right? Yeah. And that's the game. That's the game. And so I think there are about 4 or 5 more of these that you just do for the homework. Okay.
So how many questions on homework?
I think 13 for the first one, yeah. So let's just look and see. So then, like all these pages, I put both homeworks together. So then there's that one. Also, and the rest of them. Oh, so this is a formula for area, which we'll talk about in just a second. Those two are for area, and that's a word problem. And so then that's another word problem. So there are only 11 problems. So yeah, those are all the ones that you have, right? So there was no triangle. There was one triangle. Was there one triangle? Did we do one with one triangle? Yeah, and then there was 2 triangles. Yeah, right.
I got 1.7.
Let's rectify this.
Yeah, how did y'all get that?
I think I put it in wrong or something.
Okay, no, we'll figure it out. We'll put it in during the break. Okay. All right, so for 8 and 9, that's just a formula for the triangle that just involves all the sides for the area. Okay, so, here you're just using very nice stuff here, right? So we already have this. So this is just 1/2 BC, the sine of A. 1/2 BC, the sine of A. This is 1/2 AB, the sine of C, right? We already derived this formula for the area of a triangle, right? If you have 2 sides and the angle in between, then that's just calculating. So just plug that stuff into your calculator. Number 10, try and draw this picture. This is probably going to be on the final 2. I'm going to tell some ridiculous story. It's going to be about a triangle. I'm going to give you some sides and at least some angles out. I'm going to ask you to find every 2 other sides, right? Try and draw this triangle. 2 fire lookout stations are 23 miles apart. Station B is directly east of Station A. Both are now seeing a fire. Here's this word again. The bearing of the fire from Station A is go north 35 degrees east. The bearing from Station B is go north 30 degrees west. How far to the nearest 10 is the fire from each station? Right? Try and draw that triangle, see what it looks like. And so, yeah, you get good enough at these. It's not going to really matter what type of silly story they tell you. You just need to draw the picture correctly, right? Right, so talking about that. So 2 stations, one is east of the other. So we're talking about, okay, so which one's east of which one? B is on the right. B is here. A is here, right? What's this distance right here? 23? 23 miles. Got some fire up here going crazy, right? Got to get some angles. The bearing from A is north 35 degrees east. This is 35 degrees. That's right. We might as well just end it, right? That means that's 55, right? From B, it's north and then tilt 30 degrees west. That's 30, which means that this is 60. And here we are again with angle, side, angle. And of course, you just find those 2 sides like we did before. So yeah, that's not going to be a problem at all. And then 11 is another word problem where they just give you the picture. We'll take a look at it in a second, but I'll take questions about this. Okay, so then it's just asking for what's the length of those 2 sides. You know this angle, so then it's just the sine of that angle over this equals, and you just get to work. What does this picture look like? I don't think this picture can look like anything that will remotely scare us. All right, so 5. Okay, so a tower. Can we see that big enough? Let's view. Let's go in. A tower. You almost don't even need to read the question, right? Just find out what's unknown, right? So yeah, it's angle side angle. Apparently they're looking for B. What, I don't even care what the problem says, right? We got a triangle. We have angle side angle. We can find B easily. But it says a tower leans at an angle of 84.7 degrees. The figure shows that 162 feet from the base of the tower, the angle of elevation to the top is 51.6 degrees. Find the distance to the nearest foot from the base to the top of the tower. Yeah, we're looking for B, and it's the same thing. We'll break there. We'll come back. We'll answer the question. If I give you all the sides, how can I find every angle? If I give you 2 sides and the angle in between, how can I find every angle in every side? It's called the law of cosines. I'll derive it, and then we'll use it, and then we'll end for today.